Otherwise, we will be running all together. Do you notice that for some of the indirect effects, I put down a remark which hypothesis is testing? Okay. In fact, when we develop these neo-defined parameters, we need to look at the hypothesis to see what indirect effects are required. Now I'll go back to those indirect effects very soon. This is still running. The hypotheses were included starting from slide 82 until slide 84. Slide 82, 83, and 84. I have my results. Have you got your results?
Yes.
Good. Okay. Now, what I'm going to do, need to move the chat, and then I need to make this bigger so that I can read it. Okay. From the results, the first thing we need to do is to check your fit statistics. Our model has 4 degrees of freedom, chi-square is 6.38, so it is very good fit. CFI is 0.995, RMSEA 0.041, and SRMR 0.023. So our model fits the data well. Then we can interpret their parameters. Now, I'll refer to this diagram so that you know which one I'm referring to. Now, first, hypothesis 1A, extroversion will be positively related to ambitious value. Extroversion is here. Ambition values is here. So we are talking about this path, A11. A11. If we look at our outputs, I'll just look at the why I cannot move. Yes. I can't move my screen. Don't know why. Oh, yeah, okay. Yeah. So these are the outputs. We have to label, we have to estimate. Don't look at the standard error and the Z or the p-value because this is based on the Sobel test. Instead, because we run bootstrapping, we can look at the CI lower and CI upper. For A11, path A11, the estimate is 0.153 and the confidence interval, 95% confidence interval is from 0.078 to 0.229. So 0 for outside, because both are positive, 0 for outside the confidence interval. That means 0.153 is significant. Okay? So what that means is this path, our hypothesis 1A is significant. Therefore, 1A is supported. Can you follow?
Yes.
Okay. 1B, extroversion, positively related to job search self-efficacy. So we are talking about this path, job search self-efficacy is here. Extroversion is here. So this is A12. Okay, if we look at the outputs, A12 is here, the third row. The estimate is 0.294 and 0.04 outside the confidence interval. So this is statistically significant. So H1B talking about this path is significant and this hypothesis is supported. H1C, extroversion is positively related to perceived job challenge. Perceived job challenge is here. So we are talking about A13. Now, if we look at A13, the estimate is 0.245, and it is significant because zero fall outside the confidence interval. In other words, this is significant and H1C is supported. H1D, extroversion, positively related to job satisfaction. Here, job satisfaction. Now, a lot of people made a mistake. When they look at this hypothesis, H1D is extroversion will be positively related to job satisfaction. A lot of people make the mistake by looking at B51, which is incorrect. Because when we say extroversion positively related to job satisfaction, we should estimate the total effect from extroversion to job satisfaction. So it will be B51 plus A12 times B11 plus A13 times B21. Can you all follow?
Yes.
Again, extroversion, okay, positively related to job satisfaction. It is not the direct effect. It should be the total effect. So it is B51 plus A12 times B11 plus A13 times B21. Then look at the outputs. I think we have defined this here. Extroversion to job satisfaction. It is a total effect. The estimate is 0.199 and the confidence interval is from 0.098 to 0.313. So this total effect is statistically significant. Therefore, we will conclude H1D, the total effect from extroversion to job satisfaction is supported. Finally, H1E on slide 82. Extroversion is negatively related to job search behavior. Again, it is not C11. It should be C11 plus A11 times C31 plus A12 times C41 plus A12 times B11 times C81 plus A13 times B21 times C81 plus A13 times C51. So we add up all the possible paths to get the total effect from extroversion to job search behavior. Okay, so you need to be very careful about all the paths. For example, extroversion going through PJC, you can do it directly. So it can be A13 times C51, or it can be A13 times B21 times C81. Go to the next line on the output file. You can see that we add up all the paths here. And the estimate is minus 0.071. And since both the lower limit and the upper limit have a negative sign, that means zero falls outside. So this total effect is statistically significant and it is negative. Therefore, we will conclude that the total effect from extroversion to job search behavior is negative and significant. Therefore, hypothesis H1E is supported. Okay? Hello?
Okay.
Okay. So okay. So I got a message that the We got several questions from Tsinghua. First, the question is her 95% confidence interval is slightly different from my results. It is very plausible because bootstrapping is based on drawing random samples 2,000 times. Your 2,000 random sample and my 2,000 random sample may be slightly different. Therefore, the estimate should be the same, but the confidence interval may be slightly different. If we increase it to 5,000, probably they will be the same, but 2,000, there may be differences at the third decimal place. So this is the first question. The second question is number of observations 362. Any minimum sample size requirement before conducting bootstrapping? The answer is no. You do not, there's no minimum sample size for conducting bootstrapping. You can have a sample size of 5 to conduct bootstrapping. But if you only get sample size of 5, you cannot estimate this model. You need to have a sample size larger than the number of estimated parameters. That is the minimum. Now, what is the difference between a smaller sample size and a larger sample size in bootstrapping? If you have a larger sample size, your confidence interval will be narrower. That means it is more accurate and more useful. If your sample size is very large, it's very small, if your sample size is very small, this confidence interval will be very large. Therefore, it has lower power. That means it has a high chance to include 0. And you will conclude that there's no statistical significance. Okay, so some people think that, hey, bootstrapping is so good, so we can have a smaller sample size. The answer is no. If you have a smaller sample size, you will find that the confidence interval will be wider. If the confidence interval is wider, then it is more difficult to get a significant result. That means it has a higher chance to include 0. So the third question, I think I have answered, is sample size increase. If you increase the sample size, it will change the range of the confidence interval. Okay, so whether it is wider or narrower, the narrower it will be more powerful. Whether it will make it more consistent depends on the number of bootstrap samples. Now we have 2,000. If you get 5,000, probably we will get the same result. If you do bootstrapping only 200 times, then every time you may have a different confidence interval. Now, do you see the impact? Different sample size and different bootstrap samples. Xinhua, have I answered your question?
Yes, those are very clear.
That's good. Okay.
Thank you.
So Maxwell asked the question, okay, confidence interval can help us to evaluate the two-tailed test. So he's a bit confused because our hypothesis is about positive or negative. So it is a one-tailed test? No. Okay, so let me move my screen here. So our hypothesis, although we are talking about positively or negatively related, as in most of the empirical studies, we are conducting two-tailed tests. We are not conducting one-tailed test because this is only our hypothesis, but the effect can either be positive or negative. So we are conducting a two-tailed test. Even though the hypothesis is about positively related or negatively related, we need to conduct two-tailed tests. If you include a one-tailed test, if you use a one-tailed test, people will say that you're cheating. Okay? This is answer number one. The answer number two is, can we use confidence interval to test a one-tailed test? The answer is yes. We either look at the upper limit or the lower limit. Okay. Today, I'm going to tell you when we test the reliability, convergence, and discriminant validity, we are going to conduct a one-tailed test instead of two-tailed tests. Okay. So now, hypothesis 2 is basically the same as hypothesis 1, so I'm not repeating. Hypothesis 3, ambition values will be positively related to job search behavior. Hypothesis 3 is here. Ambition, job search behavior. You will notice that there's only one path from ambition to job search behavior. It is CV1. So we will look at our results, check our results, and find out where CV1 here. So it is 0.172, and the confidence interval doesn't include 0. So again, it is significant. So H3, this path is significant. Now I'll move on to slide 83. H4, job search self-efficacy will be positively related to job satisfaction here. So here we only get one path, is B11. Okay, H4A is about this path. B11, try to find out B11 here. Okay, it is 0.160. 95% confidence interval is from 0.026 to 0.286, so it is significant. So H4A is about this path and it is significant. H4B is about positive relationship between job search self-efficacy and job search behavior. Here you can see that we have two paths, C41 and then B11 times CH1. So we are talking about the total effect from job search self-efficacy to job search behavior. Remember, when you read journal articles, sometimes they always make mistake by just looking at the direct effect. It is not the direct effect. If you want to test this hypothesis, you should add the direct effect and the indirect effect. Job search self-efficacy to job search behavior. So we add the indirect effect and the indirect effect and the direct effect. The estimate is 0.107 and the confidence interval is from 0.028 to 0.189. So this is supported. H4B is also supported. So we find significant effect from job search self-efficacy to job search behavior. It has two components, a direct effect and an indirect effect. Now do one more. H5, perceived job challenge, positively related to job satisfaction. So we are talking about this path, B21. Look at B21 here. So we find B21 estimates 0.314 and it is significant. So H5A is supported. H5B, perceived job challenge negatively related to job search behavior. Again, we are not talking about C51, we are talking about C51 plus B21 times CH1. So there's an indirect effect and a direct effect. Here. We have C51 plus B21 times CH1. The estimate is minus 0.073 and the confidence interval does not include zero, so it is significant. That means we have found a significant total effect, negative total effect from perceived job challenge to job search behavior. So H5B is also supported. Can you all follow up to now?
Yes.
Yeah. Okay. So H7, H8 are pretty much the same. Or H8 is about job satisfaction negatively related to job search behavior. We are talking about C81, which is hypothesis H8. C81, if you look at C1, it is negative, and the confidence interval doesn't include zero. So this is also supported. Hypothesis 9, the effect of extroversion on job satisfaction will be fully mediated by ambition, job search, self-advocacy, and perceived job challenge. So we already find, well, in fact, it doesn't go through ambition. It only goes through job search, self-advocacy, and perceived job challenge. But when we talk about whether these mediating effects, okay, in this hypothesis, I will first say that it doesn't go through ambition values because the authors didn't hypothesize this indirect effect. But for this hypothesis, mainly talking about whether these mediation effects are fully mediated or partially mediated. It depends on the path, the direct path B51. If B51 is significant, then it is a partial mediation. That means not all the effects go for these mediators. There's something left. If B51 is not significant, then all the effects from extroversion to job satisfaction goes through the mediators. So in answering this hypothesis, we need to look at the significance of B51. B51 is here. The estimate is 0.075, and it is not significant. It is not significant. Okay, so what that means is this path is not significant. So all the effect of extroversion to job satisfaction has to go through our mediators. That means it is a full mediation, fully mediated. Okay, so H9A is supported. Now, how about job search behavior? From extroversion to job search behavior, we need to look at the direct path, C11. C11 is minus 0.106 and 0 fall outside the confidence interval. That means this minus 0.106 is significant. What that means is this path, this direct path is negative and significant. What that means is extroversion go through these three mediators to job search behavior, but it is not a full mediation. It is a partial mediation because there are some effects not going through these mediators. Therefore, H9B is not supported. H9B talking about whether these mediators fully mediate the effect from extroversion to job search behavior. We look at the direct effect, and the direct effect is significant. Therefore, we conclude that it is partial mediation, not full mediation. So H9B is not supported. Did you all follow what I've done?
Oh, yes, sir,
Yes.
but I do have a question.
Yes.
So, sir, you say is that which one? Which one is the negative? You just show us the negative and the significant.
Okay. Now, the hypothesis Hypothesis 9b is talking about the effects of extroversion on job search behavior will be fully mediated by ambition value, job search self-efficacy, and perceived job challenge. So we are talking about extroversion and job search behavior. Extroversion, job search behavior. It goes through some mediators here. There's also a direct path, C11 here. Okay, so in answering to answer this hypothesis, we need to see whether C11 is significant or not. If C11 is significant, that means not all the effects go through your mediators. Then it is a partial mediation. Then we reject the hypothesis because the hypothesis talks about full mediation. If C11 is not significant, that means all the effects go through these mediators. Then we will support a full mediation effect. Therefore, we look at C11. The significance of C11 here, 0 for outside because the lower limit is negative and the upper limit is also negative. That means this estimate, C11 minus 0.106, is statistical significant.
Yes. And then
In other words, this path is significant. What that means is the effect of extroversion on job search behavior do not necessarily go through these mediators. So it is not a full mediation. It is only a partial mediation.
yes. And for a naive reviewer, assuming I'm that person, and I found the C11 to be negative, which is strange because extroversion, that means we are outgoing and then we are not going to do the job search well because C11 is negative. That would be contradictive to a theory? Oh, of course, and that may be outside of the today's workshop, but I just want to point it out that seemed to be a little bit contradictory to my naive common sense.
Okay, well, you need to read the
Literature,
article. The citation is at the bottom
yes.
because actually the authors hypothesize that extroversion will be negatively related to job search behavior.
Okay,
Okay, this is their hypothesis.
got it.
Okay, so that is what they hypothesize, and it shows that there's a negative effect.
And
Okay.
yes, and one more question. And talking about say just the A11 and the C31, A11
A11 and
and
CP1.
C31, and is that possible? A11 is not statistically significant, but the A11 multiplied by C31 becomes significant. If that is the
Okay.
case, what should we do?
There's a good question. Okay, it depends on how you put down your hypothesis. If you like what we did yesterday, suggested yesterday, first, like the authors, they first hypothesize a significant effect from extroversion to ambition. Then they put a hypothesis, ambition to job search behavior. Then they talk about the effects from extroversion to job search behavior goes through ambition. Then you need to have all paths significant. Otherwise, is it possible that A11 is not significant, CV1 is significant, and the indirect effect is significant? The answer is yes. The answer is yes, because when you talk about significant or not significant, you are reducing all the information about A11 to 0 and 1. 0 is not significant, 1 is significant. Right? CV1 again, you are talking about whether it is significant or not, so it is 0 and 1. So some people says that you must have A11 significant and CV1 significant in order to have a significant indirect effect, because if you multiply 0 with 0, 0 with 1, 1 with 0, they are all 0. only when you multiply one with one, that means significant with significant, then you get a significant indirect effect, right? That is one rationale, and it is incorrect. The reason
Wonderful.
is, the reason is when we talk about A11, it is not 0 and 1. It has an estimate. It has a standard error. In fact, when you say it is not significant, it may just miss. Maybe the p-value is, it is your unlucky day, it is 0.052.
Yes,
get
I
my
got
point?
it. Thank you.
It may be
wonderful.
0.052, and this is maybe very strong. When you multiply the two together, the A11 times CV1 may be very strong. Okay, this is point number one. The second point is we will then be talking about the standard error of the indirect effect. We are not talking about the standard error of A11 or the standard error of CV1. We are talking about the standard error of the indirect effect. So it is a totally different test.
Thank you.
So when we test the indirect effect, we should not just look at the significance of this path or the significance of this path. We should look at the significance of the indirect effect. Of course, it may be a little bit challenging for you to explain to the reviewers that if A11 is not significant, the indirect effect is still significant, right? Do you get my point?
Yes, got it.
Okay.
Outstanding. Thank you.
If you want to explain this, I can give you a citation. My ORM paper in 2008, my organization research methods paper talks about this. Okay, it's not necessary to have a significant A11 for a significant indirect effect. Okay, are we all good on this example?
Yes.
Good. Now we can move on to talk about measurement model. Let me rearrange my screens. Okay, now. So today we are going to talk about measurement model. Yesterday, I mentioned that there are two benefits of SEM. The first benefit is when you have multiple relationships, like what we have here. There are many relationships, okay? We can estimate all the paths in one analysis. We can estimate all the paths at the same time, okay? So that we won't make any mistakes. If you use regression, you will have 7 different regression equations, and you need to estimate them one by one. If you estimate them one by one because you do not allow this to query, your estimates may be biased. So the first benefit of SEM is it will allow you to estimate all the paths, all the hypotheses in one model. And remember, when you use SEM, you should incorporate all the hypotheses in one model and test this final model. The results should be based on that final model. The second benefit of SEM is to parcel out the measurement errors. Yesterday, the path analysis is assuming that all the measures are observed variables. So you can see that in our diagram, these are all in boxes. These represent observed variables in SEM. However, in a lot of psychological constructs, for example, attitudes, perceptions, behavior intentions, etc., they are not directly observables. They are latent variables or constructs. Now you can see that I have two constructs or factors here. They are in circles. In SEM, you use circles to represent factors or constructs which are not directly observable. And you can see that in this diagram, I use 4 items to measure factor 1 and 4 items to measure factor 2. If you remember our classical two-score model, x1 equals to the true value of factor 1 plus delta 1. That is the classical two-score model. Okay, so x1 equals the true value of f1 plus delta 1. The relationship between f1 and x1 is called lambda 11, the factor loading. This is actually a regression coefficient. x1 equals to lambda 11 times f1 plus delta 1. So we can have different equations. Now here we have 4 equations, here we have 4 equations, okay, to represent the factor loadings. The 511 here refers to the variance of factor 1. 522 here refers to the variance of F2. 512 refers to the covariance between F1 and F2. Now, do you all understand the symbols in this figure? We have 8 items. Because these are items or indicators, they are observables, so they are in boxes. But they represent 2 latent constructs or factors, therefore the factors are in circles. The 5 refer to the variance and covariance between the latent variables. The lambda factor loading refers to the relationship between a latent variable and an indicator. And then we have the error term for the measurement. Now, one thing I need to mention, although we draw like this, the error terms, yesterday we also talked about these are random measurement errors. Delta 1 to delta 8, they are random measurement errors. Because they are random, the mean is 0. So we are not talking about the value of delta 1 here. We are talking about the variance. When we talk about the size of a measurement error, we are referring to the variance of the measurement error. We are not talking about the mean of the measurement errors. The mean of all the random measurement errors are assumed to be 0. When we talk about the size of measurement errors, we are referring to the variance of the measurement errors. So we are referring to the variance of delta 1, variance of delta 2, variance of delta 3, and variance of delta 4, etc. In this diagram, you will also notice that we do not add any covariance among the residuals. In the past, when you read journal articles that publish like 10 years ago or more than 10 years ago, people cannot get good fit. People cannot get good fit of the model, and they use modification indices. And they find that delta 1 and delta 2 may be correlated. Therefore, they add a covariance to improve the model fit. This is not acceptable in management studies, marketing studies, and psychological studies. If you add a covariance here, that means x1 and x2. In addition to a factor f1, there's another factor f3 that's related to x1 and x2. So we never add a covariance here. You cannot add a covariance among the residuals except under a very special circumstances. What is that special circumstances? Is if x1 and x5 are the same items. For example, f1 is the construct at time 1, f2 is the construct at time 2. So x1 and x5 are the same question, but you measure at different time points. Then we can covary. the residuals because there is some errors because of the wordings of the item. So we also covariate delta 2 and delta 6, delta 3 and delta 7, and delta 4 and with delta 8. Another possibility is if F1 is self-weightings, F2 is supervisor weightings. And if we use the same item, X1 and X5, then we can covary delta 1 and delta 5, delta 2 and delta 6, etc. So there are two situations, but actually they are one situation is if and only if you use the same item at different time points or from different sources, then you can covary the residuals. Otherwise, you cannot covary the residuals. If I see a submission, they covary the residuals, I will reject the paper and ask the office to rerun the analysis without the residuals because they cannot explain what is a covariate residual. And a measurement model, some people always confuse between a measurement model and confirmatory factor analysis. We use a measurement model. We estimate these parameters to conduct a confirmatory factor analysis. What is a confirmatory factor analysis? It is actually a test of hypothesis because it is confirmatory. It is a test of hypothesis of this model. In this particular model, we hypothesize that the first 4 items measure factor 1, the last 4 items measure factor 2, and factor 1 and factor 2 covary. This is our hypothesis. We use a confirmatory factor analysis to test our hypothesized model. You may have heard about exploratory factor analysis. Exploratory factor analysis, we start with 8 items. We don't know how many factors and we don't know how they are related. We use exploratory to find that out, exploratory method to find it out. So in confirmatory factor analysis, if you are conducting a study, an empirical study, you should use confirmatory factor analysis, CFA, to test your measurement. You should not use EFA, exploratory factor analysis, because EFA starts with 8 items, X1 to X8. You don't know how many factors you have. You don't know how the items are related to each factor. And actually, you don't know what are your factors. Before we have structural equations modeling, researchers use EFA to test your measurement model. So they run an EFA and they conclude that they have 2 factors, the factor loadings are loaded on those. But EFA is more unstable. EFA is more unstable. There are a lot of times you cannot find the same factor structure from EFA. If we compare CFA and EFA, in EFA, all indicators have loadings on all the factors. For CFA, you specify which indicators load on which factor. If you remember, for an EFA, exploratory factor analysis, you have factor loadings for all items on all factors. But here, in CFA, we hypothesize that X5 is not measuring F1, X6 is not measuring F1, X7 is not measuring F1, X8 is not measuring F1. If you run an EFA, then you have a factor loading here. They may be small, but you still have these factor loadings. But in CFA, we hypothesize those to be 0. CFA, it is possible to fix the loadings for given indicators. That is what we are going to do next week when I come. When we compare a measurement model across groups, okay? So we may want to say that, hey, this factor loadings is equal or not, whether this is equal or not across group. So this is what we can do with CFA, but we cannot do with EFA. In this particular model, we may want to say that, hey, whether lambda, for example, this is self-weighting, this is supervisor weighting. We may want to test whether lambda 5.2 and lambda 1.1 are the same or not. You can test it with CFA, because that determines whether the supervisor construct exactly has the same psychometric property as self-weightings of the construct. So we will test whether the factor loadings are the same across time or across sources. In EFA, this covariance, okay, you can say it is 0. Then in EFA, we will ask for an orthogonal rotation, or we use Varimax. Okay, we allow this to covary. In CFA, we can specify the value of this. Okay, in fact, I will mention it later today. A lot of researchers fix their correlation to 1 and say that, hey, okay, F1 and F2, whether the correlation between F1 and F2 is 1. If it is not 1, then we are talking about 2 constructs. If it is 1, then we are talking about 1 construct. That is how we test, how people test discriminant validity. But I will tell you later today that it is not a very good test. In EFA, we assume that all these measurement errors are not correlated. As I mentioned earlier, in CFA, you can specify the measurement errors to covary. The reason is if you use the same item across different time points or across different sources. So CFA gives you a lot more control on your model. That is how you use this to test the measurements quality of the quality of your measurements. EFA is exploratory. You don't have any control, and you let the program, you let the data tells you what your model looks like. Now, do you have any questions between CFA and EFA? Remember, when you conduct an empirical test, when you develop your survey, you should know which item is measuring what construct. If you don't know a particular item, what it is measuring, then you should not include it in your survey. What that means is, in all empirical studies, you should conduct CFA, because when you collect data, before you collect data, you know what the items are measuring already, and you want to test whether your data should support your hypothesized model. Unless you are developing a new scale, then you don't know what the items are measuring, then you will run EFA, exploratory factor analysis. Otherwise, you should run a CFA, confirmatory factor analysis.
Can you go back to the measurement model? The figure. Yes, sir. And suppose empirically, and I'm adapting a scale developer by some well-known scholar like you,
Okay.
and then I utilize a different sample. I found that empirically, the delta 1 and delta 2 are highly correlated. That seems to suggest the multi-collinearity. And then would you recommend me to maybe get rid of, say, X1 or
Yes.
X2?
Yes.
Okay.
Just drop. There are 2 ways you can do it. You can drop
Yes.
1 item or combine the 2 items.
Okay. Thank you.
Okay. Well, why don't we take a 10 minutes break? And then I will move on to talk about the empirical study, how we can examine the quality of our measurements. Okay? Let's take a 10 minutes break. At 10:15.